for you. Can you tell me, please? Am I audible? Hello.
Yes, sir. Yes, sir. Very much audible, sir.
Yes, sir.
Yeah. No, what are the topics have been covered by madam in the last class? I want to know because I was not there. Noor?
Yes, sir. Just a second.
Yeah.
Sir, she covered unit 1,
Hmm.
2, and 3. I'm not
Three
wrong.
also she covered.
She gave us also a few websites to have a look into.
No, not
Those
the
we read
website.
from the book.
It's the other thing. I want to know what are the topics, what are the units here. Did she discuss about stack? It's very important one. Stack.
I don't think so, sir. Because she was reading from the book itself. I mean, you know how the book is, sir. It's full of information. So we couldn't get much from it, sir.
Okay, fine. So you are not sure about what are the topics you have been covered exactly. So not having idea.
స్టాక్స్ చెప్పారు సార్ మేడం.
ఓకే, ఏం చెప్పారండి స్టాక్ లో?
స్టాక్స్ లో చెప్పారు, ఇది మెథడ్స్ చెప్పారు, ఇంప్లిమెంటేషన్ ఆన్ స్టాక్స్ అవి చెప్పారు. ఇది ఓన్లీ అప్లికేషన్స్ ఇట్లా పైన ఎక్స్ప్లెయిన్ చేశారు. డీటెయిల్స్ గా కావాల్సి అంటే వెబ్సైట్ లో వెళ్ళి ట్రై చేసి చూడండి అని చెప్పారు.
Okay, I'll discuss about first of all I want to discuss with you what do you mean by one important word, that is ADT. Just remember that you'll get this word whatever I discuss in the class. It is very important. Do you know ADT? ADT means abstract data type. Are you able to access some screen?
Sorry, sir.
Are you able to see some screen?
No, sir.
Just a minute. Hold on. Am I audible now?
Yes, sir. And your screen is visible again.
Yeah. ADT means abstract data type. What do you mean by data type? ADT, abstract data type. Can someone define if you know it? What do you mean by data type? What do you mean by data type? You know data type. You have learned about in C and Python and Java. What do you mean by data type?
Ma'am, does a data type means collection of data?
No. That's not the collection of the data. It is the type of the data that can be used by a computer program. Like data type is basically it is the type of the data. It means which data you are going to use in the program. Means you may use integers, you may use float, you may use decimal, you may use long or boolean or anything. So the data type is the type of the data that can be used in a program. Is it clear?
Yes.
Now, what is abstract data type? Abstract data type is also a special kind of data type. How can we know? It's also a special kind of data type, and its behavior is defined by a set of values and set of operations. What do you mean by abstract data type? An abstract data type is a special kind of data type whose behavior is known by its values, set of values and set of operations. So an abstract data type can have set of operations and set of values. Just remember that. Simply, whenever you get this word abstract data type means that it will have some set of values, it will have some set of operations. Is it okay?
Yes,
What are the set of values and what are the set of operations? We will see. Whenever you see the abstract data type, it will have some values, set of values and set of some operations. Just remember that. Now we will see about list data type. That is there, I think, unit 3. List data structure we have. A list data structure is an abstract data type. What do you mean abstract data type? It's a data type. It will have set of values and set of
operate.
yes, set of values and set of operations. Based on these only, the abstract data type behavior can be identified. Abstract data type. So we have the topic list data structure. It is important one. List data structure. What is the list data structure? You may get this question in the exam. What is list data structure? Explain about linked list, single linked list, double linked list, and what are the types of linked lists. We will discuss. List data structure. It is a list data structure is an abstract data type. And the list data structure elements are stored in a what do you call in an order. So that is easy to what do you call easy to retrieve and easy to store. List data structure is a data structure whose elements are stored in an order, easy to retrieve and easy to store. And list data structure also allows repetitions. What do you mean by repetitions? Means a single element can be repeated more than once in the list. Example, it may have some multiple values, set of values we said, like 5, 6, 5, 2, 5. Here, repetitions is also possible. List data structure is a data structure whose elements are stored in an order, and it will allows repetitions also. That means that a list data structure will have its values. It allows values to be repeated, and values may also be distinct. Values may be repeated and may be distinct. And it's like a it's like an array. You know array?
Yes, sir. Repeated data.
Yeah, array will be like this. What do you, can we store 3.5 and a x? Can we store array? And array be like this?
Array is a compounded data type, right, sir?
Yes. Array is a data type which will have only homogeneous elements. Means homogeneous elements in the sense an array can store only particular type of elements. Like if you define an array int a of 5, this can store 5 elements of only integer type. Like we can say only integers 3, 2, 4, 0, and anything 9. This is the right one. And this is not like 3.2, 5, and a like 6.5. This is wrong. Actually, means we have defined an array that is integer type. It can store only integers. The size is 5. Means what do you mean by an array? Array is a data type. It's a data structure that can store only homogeneous elements. What do you mean by homogeneous elements? Means all the elements are belongs to the same data type. Here we have taken integer. Only integer elements can be stored in the array A. You cannot store decimal elements, and you cannot store character elements. You can store decimal elements if you declare the array an integer, but that can take only 3. Integer part only will take, and it won't accept characters like this. It will accept only integers like this. So an array, uh, a linear data structure is like an array, but in a linear data structure, we can store distinct elements. But in array, we can store only homogeneous elements. You got the difference between array and list data structure? What do you mean by list data structure? List data structure is an abstract data type. It can store multiple values and it will have set of operations. The values can be repeated. It's like an array, but array will store only homogeneous elements, and this list data structure can store distinct elements. Means different elements. Means if it is a list data structure, you can store decimals, you can store integers, you can store characters, you can store strings, anything you can store. Got it?
Yes, sir.
So, in array, you have to give the its size fixed. This is called static size. Means if you give b of 6, means this is the array int b of 6, means this array can store only integers and that can store maximum of 6 elements. But list size is list data structure size is dynamic. Means no need to specify the size. You can give the number of elements. If you want to store 10 elements, that can take 10 elements. That is dynamic. And list data structure can have mixed data type. It can store decimals, integers, and
what are the examples for list data structure? List data examples of list data structures are stacks and arrays. Sorry,
lists. So lists are the we have 3 types of lists here. Queues and 1 minute. You have idea about definition of list data structure? Please respond. List data structure.
Yes, sir.
Yeah, list data structure is a data structure that is used to store the elements or store the data elements into a memory to store efficiently and to retrieve efficiently. And list data structure is an example of ADT, abstract data type. You can see the word ADT or abstract data type may in the question paper. ADT, abstract data type. Abstract data type is nothing but, and it's a data type whose behavior is identified based on its values, set of values, and based on its operations. ADT will have number of values and various operations on it. And list is an example for ADT. And lists can be implemented by using linked lists. Lists can be using implemented lists. Implemented using linked lists. This is important. There is no question paper without the word linked lists. Hello, Ji. So lists can be implemented by using linked lists. Do you have idea about linked list?
Not much, sir.
Important. This is very, very important. So linked list is a means a list can be implemented by using linked list. What do you mean by a linked list? A linked list is a collection of nodes. A linked list is a collection of nodes. Just try the definition. It's important one. Compulsory. What do you mean by linked list? Question will be there. Linked list. A linked list is a collection of nodes that are collectively form a sequence. Please, if you have any doubt, any confusion, or if you are not getting, let me know. These are very, very important. That's why, especially I'm taking the class. Otherwise, I could have given to somebody.
Appreciate it, sir.
Is it okay? The definition, the linked list. The
Yes,
lists can,
sir.
Yes,
list
sir.
data structure can be implemented by using linked lists. What do you mean by linked? I have written this one. Linked lists. So what do you mean by linked list? A linked list is a collection of nodes. Just underline this word. This is important for us. Collection of nodes that are collectively form a, better you write, a linear sequence. Collectively form a linear sequence. What is a single linked list? Types of linked lists. Linked lists are categorized into three. First one, single linked lists. Second one, double linked lists. Third one, circular linked lists. Just remember, single linked lists and double linked lists and circular linked lists. Got it? Have you noted down?
Yes, sir.
You can define in different way also. A linked list is a linear data structure that includes a series of connected nodes. You can write like that.
We can write some other definition. A linked list is a that this can also be can it any definition.
Is a linear data structure
That includes
a series of collected nodes, or you can change the definition also. Mirela, whatever you understood about this linked list, you can write the definition. How this
looks like. And one more thing, how this stores. And we have discussed in the previous, no? This the word in linked list. This is important word, nodes. And what is node and what we will have in linked list? This one. Each node of linked list will store data and address of next node. Remember this one. This is very important. So how this data structure will look like? Like linked list. Link will be there. Data. This is next. Data next. So this will be the this is starting head. Starting point will call it as head. So what is the data? And what is next? Two parts will be there each node. This single thing will be this is a node and this is a node. Each node will have data and its address of the next node. Means we have two nodes here. This is the first node and this is the second node. The data will be there. Example, we can write like this. The data of the first node is 2 and address is 104.
and this is for a
5. This is the address. So what is the actual element here? 2 and 4 are the data elements. Means numbers we are storing. A node linked
list will have
various nodes that will be connected by using addresses. Every node will have the one value and address of another node. Can I erase this one?
Sure, sir.
Yeah, I'll come to it. Consider we have we have a list here like 5, 4, 6, 3. We have 4 elements here to be stored in the memory. We are using linked list. So this one, this is the starting. We will name it as head. So what is the first element here? 5. 5 will come. This is data. And this will have address. See, this address is 1001. And next address. Next element will come here. This address is 100.
Yeah, let's assume. So what will come here in this box? What will be there here? Means this is for one node. To which node it is been connected? What is the address of the next node?
Am I audible? Am I audible or not?
Audible, ma'am.
But your voice is breaking a bit in between.
Okay, wait.
Voice breaking, sir.
Now let me know. Is it okay?
Yeah, it's okay, sir.
Yeah. So what I'm telling is a linked list will have nodes. Is it okay? Means this is one node. This is one node and this is other node. So what we have in the first node, data will be there. These are the data elements we need to store in the memory. So first element, first data we have taken. And every node will have data element and the address of next element. What is the address of next element? This is the address. This is the address. What happened, guys? What is the address of next element? This is the first element. This is the first node. This is the second node. What is the address of second node?
1005.
That will come here. That's what I'm doing. This one. This is an example I'm taking. And if we have one more node here, no? What is the next element to be stored?
6.
6 will come here. And what will be there here? Like this is a 100 or 9. What will come here?
1009.
9. So every node will have two parts. One part is for data and second part is for address of
Address.
Why next node? This is a linked list. One nodes will be connected each other through the addresses. So if I want to find what is the next element of 4, what is the next element of 4? How can I know? I will see the address part. What is the address of 4? And we have two fields, no? Data field and address field. What is there in address field of 4, element 4? We have data element 4 here, no? What is the address in the address field?
1009.
1009. You will see where is 1009. Here. What is the element here?
6.
6. So in this way, why should we use the address part in a node? Because to identify its predecessor and successor. What is the next element of that node, that element, and what is the previous element of that element? Got it? Using this address only, we can find out. So linked list will have like this. So you can have like this. Next we have 3, and this is something. If there is no element to the next, simply we will put as null. What happens if there is no next element? This will become null. There is no. Here, this will have like 1010. This will come here. This is what you call. This is called singly linked list. Have you understood something or not? If you are not getting, and I'll explain it again.
Could you repeat that again, please, sir?
Sorry.
Could you go over that again, please, sir?
Again?
Yes, sir, please, if you don't mind.
No issue.
Thank you, sir.
From where you want me to continue?
On the addresses, sir.
Yeah, you got the concept of what is list, linked list.
Yeah, that I understand. It's just that the addresses and how to determine the next one.
Fine. Okay. In lists, we are discussing about list data structure, and list data structure can be implemented by using linked lists. Linked lists, we have three types: single linked list and double linked list and circular linked list. In single linked list, nodes will look like this. In a single linked list, if we will explain this linked list with the help of nodes. Every node will have two parts. In a linked list, every node will have two parts. One is data part, and other is the address part. Every node in the linked list will have two parts. One is the data part and other is the address part. Data part will have the actual element to be stored in the memory. Example, if you take three elements to be stored in the using data structure like 2, 4, 5, we need to store these three elements in the memory using data structures. You can choose any data structure. So I have chosen linked list data structure. So I am using the single linked list. If it is the starting element, we will name it as head. Head indicates that this is the starting element, starting node. So this is the node 1. We will have two parts now. In the first part, we will store anything, means any element. I am storing here as 5, and it will be connected to the one more node, because linked list is a collection of nodes which are connected together. That will be in a sequence manner. See, list, these are connected. How connection can be done using arrow symbols. So second element, I'll take any element. I'll take 2. Actually, I want to store the three elements. They are 2, 4, 5. Order may be different. First I am storing 5, and next I am storing 2, and next I am storing 4. This will come here. So there may be some addresses like every node will have their addresses. This is 2006. This is 2009. This is 2004. Consider this is the address of first node, address of second node, address of third node. So what will come here? Every node will have element data part. In data part, it will have value, actual values to be stored in the memory. And next part will have the address of next node. What is the address of next node for the first node?
2009, sir.
Yeah, this will come here. Here 2004. What is the address of next node? This will come. Why should we use two parts here? Data part will be used to store the actual elements in the memory. And why should we use the address part in the node? The address part should be used in the nodes because to know the previous element and next element in the list. What is the previous element? We can't directly find out what is the previous element of 2. Previous element of 2 means if data element, you want to know the previous element of 2, we will see here 2 is there here. Previous element means it will see previous address. What is the previous address of 2?
5, sir.
Previous address I am asking.
2009.
Yeah.
2000.
Memory address can be accessed very easily and very fast. So that's why we are using addresses here. So the previous address of 2 is 2009. So what is the element is stored in the address of 2009? That is 5. So Accessing memory address is very faster and very efficient and very easy. That's why we are referring the addresses here. If you want to know the next element of 2, then immediately we will see the what is the address part in the node 2, 2004. So whatever is there in 2004 address, we will see. So address part can be used only to know the previous element and the next element in the list. This is the purpose. And what are the, we have seen in the starting and we have discussed that a list is a ADT. What do you mean by ADT?
Abstract data type.
Data type. Abstract data type is nothing but it's a data type. It will have more values in the memory. Does it have more values here? Set of values in the sense it more than one. Is it having more than one value here? How many values are there here?
3 values, sir.
3. So this is having more than one value. So this is satisfying the ADT property 1. ADT means abstract data type. It will have set of values to be stored in the memory and it should have some properties. So some operations. What are the operations can be done on lists? This linked lists. What are the operations? If I want to delete an element 2 from the memory, I don't want this element. How can I delete? This is a linked list, no? Single linked list means only single link is there. Why we are calling single linked list means only a single link will be there in the forward direction from one node to another. Single linked list is a linear data structure that will have a single link from one node to another in forward direction. Then how to delete? What are the operations can be done on single linked list? What are the operations can be done? Can you predict? No idea?
Remove, no, sir?
Yeah. You can add an element and you can remove an element. How to add?
Add అంటే మనం ఫస్ట్ లో కూడా యాడ్ చేసుకోవచ్చు కదా సార్, ఫస్ట్ లో లాస్ట్ లో మిడిల్ లో కూడా.
Yeah, you can see. You can insert. Add is nothing but we will call it in the programming language insert, and you can delete. Can you search for an element where it is exactly? Can you search for a particular element and a value and the same? Element and values are same. The terms are different. The meaning is same. Can you search for a particular element whether it is existing in the list or not? If I want to search for, I can search whether the 4 is existing in the linked list or not. So what are the operations can be done on single linked list? You can insert operation. Next, you can delete. Next, you can search for a particular element and you can sort also. Now order is different here. You can sort the elements and you can traversal.
Traversal means, sir?
It's accessing each element in the list. So insertion, these are the operations can be done using single linked list. So can you say that a linked list is a ADT? Is a single linked list or lists are ADT? Can we treat them as ADT? ADT means abstract data type. Abstract data type means it will have set of values. Whether it is having set of values 1, 2, 3. Set of values is nothing but more than one value. That's it. Does it having?
Yes, sir.
Yeah. And one more property of ADT is
Set of operations, sir.
Set of operations. If there is no operation to be done on the data structure, then it cannot be considered as abstract data type. There should be, there could be some operations are possible on the data structure. Can we do some operations on the data structure? Yes, we can. Can you see set of elements we have here? So this is satisfying this one, and we can insert more elements to the lists, and we can delete particular element from the list, and you can search for particular element from the list, and you can sort all the elements of the list. And one more thing, you can traversal of the list. Traverse means nothing but you can access all the elements of the list. So these are the 5 operations can be done on the lists. So this is also satisfying the property of ADT. Can you say that a list is a ADT?
Yes, sir.
Anybody having any confusion or any doubt in this? Yes.
No.
A list is a ADT because a list can store multiple values. A list can be implemented some operations on it. So how to see the question will be asked like this: what is ADT? How can you implement ADT? Explain some ADT, abstract data type. A list is an example of abstract data type. A list is a, what do you mean by a list? A list is a data structure. What I have given the information? Definition. I have given 2 definitions. No.
The list is a linear data structure, sir, that includes a series of collected nodes.
Yeah, exactly. A list is a linear data structure. Does it is having linear in a line? A list
Yes,
is a linear data structure. The elements are connected through the nodes. It's a collection of nodes. And
that form a linear sequence, right, sir?
sorry, tell me. Yeah.
That form a linear sequence, right, sir?
Yeah, exactly. Lists can be implemented by using linked lists. What do you mean by linked list? Linked list is nothing but collection of nodes connected together. And we have 3 types of linked list: single linked list, double linked list, and circular linked list. And we are discussing about only single linked list now. What is a single linked list? A single linked list is an example for linked list. It will have only single link to the nodes in the list. It will have a single link to the nodes in the list. And a node will have 2 parts. First part is data part, and second part is address part. The data part will have the actual value to be stored in the memory, and address part will have the address of the next node. Ee node ee element deni connect ayundi. Ee element taravana next node enti, ee element mundana next node enti. Then how to know there is no element before particular node? Example, if you take element 5, is there any element before that?
No.
No. Then how can we find out? We need to check based on the address only. If address of 5 is equals to head, what is the address of 5? Address part. Here we will call it as next here. If there is no element, if you see this one, if the element previous of 5 is equal to head, then head means there is no element. And later we will there is a part null. If the next of element is null, and the next element lo null untenemo tarvata em levani, previous element daggara head unte there is no element before. These are the meanings, and we will see what are the operations, how that can be done. So you need to explain all these in a systematic manner. So what is the first operation? We will see. We will take the same example of 3 elements to be stored in the memory. The first one is 5. And here the next one is, you can say something. This is 2004. And this is connected to 4. This is 2. This is 2006. This is the address. And this is fourth element. This is 2006. This is head. This is starting. This is last. Means there is no elements after this. This is 2005. Anything. 2005. This is so the first operation, insert. How to insert an element? How to add an element? You can, this insertion operation will be helpful to add node at any place. You can insert node at the beginning. We can insert bus classroom, room. Okay. No. Run. Classroom. I'll call later. So where we can insert, this is the question mark. You have one more extra element here. This is 5, 2, 4, and 9. Consider where we can insert the element. The possibility for the inserting element is we can add insert at the beginning. We can insert element at the end. We can insert element at the in the middle. So how to? Can you tell me how to add? Can someone? We will see how to insert node at the beginning. How to do it. So whatever we are discussing, that thing you can write in terms of matter in the exam. Can someone tell how to insert, what to do to store element in the beginning? Please, someone.
Is it by using the push function, sir?
Yeah, you know that you have address here actually 2004, right? So if you want to insert in the node in the starting, you can put one node, you can allocate memory to the one empty node. And you can, before you can allocate memory here, and you can take, what is the address of this one? The first node, actually, in the existing list, what is the address of the existing list first node?
2004, sir.
Just store the to insert a node at the beginning, you just allocate some memory to the node, and the address of the existing node, first node, you can put it in the address part 2004. If you allocate some memory, it will give some memory address to it. And if you want to insert 5, 2, 4, 9, if you want to insert 9, just insert the 9 here and just put the address of the first node of the existing list in the next part, and this will be same.
So based on the addresses, we can identify the elements, right?
Based on the addresses only, you need to see what is the address of the first element in the existing list. So this is 2004 example. So before that, you can give some memory to a node. You can allocate some memory. So automatically this will give some memory address. So whatever the address of the first node in the existing list, that address you can store in the new node. And the element, whatever you want to insert, that you can put in the data part. Automatically this will be come here and so what we have done here, so simply we are putting the address of the existing node, first node, in the new node. Any confusion in this? ఇక్కడ ఫస్ట్ నోడ్ లో ఉన్న అడ్రస్ ని తీసుకొచ్చి కొత్త నోడ్ లో పెడతాము, ఒక ఎలిమెంట్ ని దాంట్లో ఇన్సర్ట్ చేస్తాము, రిమైనింగ్ అంతా సేమ్ ఉంటుంది. Any confusion or any thing you want to?
Clear, sir. If we want to adapt that at the end means just we need to write the element name for and address 2005 means it will automatically create the new element of other address.
Order, please. Please. Because I am not getting actually your voice. Please let me know. Please, I am to explain you.
If we want to insert the element at the end means just we need to write the element 4 and address 2005 means it will get created automatically, no?
At the end, no. At the end, you should not write 2005. Now we are discussing about how to insert a node in the beginning. So what you do, you need to allocate some memory. What is the memory? Just I have allocated 2001 memory to the node. This one. So this one, see, I have allocated some memory to it. This is the memory. And I'll put this address in this, and whatever the element I want to store, I'll store here. And I'll give the link to the next node. That's it. This is the one. Next, I want to insert an element at the end. What I need to do? We have the elements like this. 5. This is 2006. This is 2. This is 2009. This is 4. This is null actually, because this is the last node. This is 2004. This is 2006. This is 2009. And this is the starting element. Can you tell how to insert? Actually, why we are putting null here means because there is no element after that in the sequence. Now, what we need to do if you want to insert a node at the end? You need to allocate some memory to a node. Means, so allocate some memory means just give some memory address. I am giving 2010. This is allocation of memory to a node. Node will be created automatically because every node will have 2 parts. One is data part and other is the address part. What we need to do? What will be changed here? You need to allocate some memory to the new node and you should give some link to it. And what about this null? What will come here?
Null place lo 2010 వస్తుంది.
Exactly. This will be removed. This will be replaced with 2010. The address part of the existing last node will be replaced with the address of new node. And if I want to insert 9 here, I can put 9 here. And what will come here?
Null, sir.
Null, because there is no other node after this. Simply, we are creating one node here and we are giving address to it, and we are storing this address in the null part of the existing node, and that null will be replaced at the address of the last node, and whatever the element we want to store, that will store in the data part of the last node. Any confusion?
Yes, sir.
Clear?
Yes.
Anybody? ప్లీజ్ చెప్పండి, మీకు ఏమైనా డౌట్ ఉంటే నేను చెప్తాను, మీరు భయపడద్దు, మొహమాటపడద్దు.
No, sir.
Okay, can I move further?
Yes, sir.
Yeah. Let me know please and how to insert a node in the middle.
Sir,
In the operation, that is insertion only. Insertion can be done in 3 ways. You can insert at the beginning, you can insert at the end, you can insert in the middle. So we have inserted in the beginning, we have inserted at the end. Now we are going to insert a node at the in the middle. So let me know how to do. I'll feel happy if someone tell me how to insert. 5. This is 2002. Address can be just example I'm taking. This is 4. This is 206. This may be 2004. This is 2002. This is 2.
2006.
No, null. This will be 2006. Now let me know if I want to insert node here between 5 and 5, 4 మధ్యలో నేను ఒక node insert చేయాలి. I want to insert the node between the elements 5 and 4. This is 5, this is 4, and this is 2. These are the elements to store in the memory. What to do?
Create another node, sir.
Sorry.
Create another node and దానికి 5 అని పెట్టచ్చు, sir.
Please let me know. Hello. One person. Some noise is coming. NS, please tell me.
Sir, if we take the address of 2002, means already it is there in 5. Then how can we?
No. What you want to do first? You want to insert a node in the middle of 5 and 4, right?
Yes, sir.
What you need? You need a node for that. See, you just break this link and the list will be like this. 5, 2002, here 2004 will be there. Now this is 4 and 2006, and this is 2002, and here it is as usual 2 and null. To insert an element between any 2 elements, you need to break the link. So if you break, that looks like this only, right? What happens if you break this link? Will it be look like same as it is here?
No, sir.
Hey, if I break this one, the picture looks like this one only. No?
We can take a new one, no, sir. We can repeat it if you want.
No, if I break the link, the link list will be look like this. So here middle, I want to insert a node. I'll allocate some memory to it. The memory may be 2009. If I want to insert 9 here, I'll insert here. Now, what are the changes need to take place?
2002.
Here, the new node address will be 2002. Then link will be given. And what about this one? Hello?
2009 అవుతుంది.
Hello? ఎవరు?
Sir, we will keep that transaction only, no?
నేను మీటింగ్ లో ఉండే.
Sir,
Sorry, friends. So what need to be changed here? So this
replace with 2009.
will be replaced with the new node address. This one, and you need to give the link. Have you understood this one? How this can be done? How you can insert a node in the middle?
Yes, sir.
Anybody?
Can you write the program, sir?
Sorry?
Program, implement the program, sir.
No. You will be asked like this. What is linked list, and explain about single linked list. What is single linked list? What are the operations on single linked list? This is an example of insertion.
Okay.
How will you do? You can show in terms of picture, you can write in terms of text. No program will be asked in the exam. The program part we will see in the practical.
Okay, sir.
Okay?
Okay, sir.
Any confusion in this? You need to understand this concept. It is somewhat difficult, but if you understood this one, this is very, very beautiful. Using this implementation of data structures only, this delivery system, like whatever the delivery system we take, like any delivery, online shopping or Zomato or Swiggy or anything, Rapido, how this can be done using the data structures only.
Sir,
Sorry?
how to delete the notes, sir?
We have seen only insertion. If you have any doubt in the insertion, how to insert node at the beginning, node at the end, node in the middle, let me know. Then we will move for the next one, deletion.
Okay, sir.
If you have any doubt in the insertion, please let me know.
No, sir.
Okay, fine. Let us see this one. How to delete a node. Example, if you want to delete the node 4, what you need to do? You need to break the links. That's it. If you'll search for the node where it is, and you can see, is there any node before that? You need to check. And is there any node after that? You need to check. To delete a node, you need to check whether it is having any predecessor. Predecessor is nothing but a previous node. And is that node, is there any node for it as a successor or a next node? Whether the node is having previous node and next node. Whether it is having, if it is the 4, if you want to delete, whether it is having previous node.
Where, sir?
No, this picture. I'm telling you about this picture. This one. This is a node. Consider this is connected. This connection is there. This is connection like this, and this is connection like this. If you want to delete 4, if you want to delete node 4, you need to check whether that node is having previous node and whether that node is having next node.
Yes, sir. Previous node.
Yeah, if it is having previous node, just break the link. If it is having next node, just break that link also. And you need to link these two here. Confusing?
Just to write.
Wait. I'll clear the picture and I'll draw it again. No, don't worry. You have head in the starting. This is 5. This is 2003. This is 4. This is 2006. This is 2003. This is 2004. And this is 9. This is null. 2006. And let me know whether 4 is having any previous node. Yes. Then break this link. Whether this is having next node. Yes. Just break this link. Then these two should be connected, no?
Yes, sir.
Yeah. How to connect this one? Just make this link to here. How this will come? 5 will come, 2003 will come, 2004 will come.
Like the 9 null 2006 will join with that, right, sir?
Yes.
It will be replaced, sir.
Is there any changes required in the blue color picture?
Yes, sir. 4 element has been deleted.
Yes. What is the next node of 5? Address 2000. This should
2006.
That's it. You need to link the node to the next one. You need to change the address here. Whatever address is there here, that address you need to put it.
Understood, sir.
Understood?
Yes.
Yes, sir.
Yes, sir.
Okay. If you want to delete, example, if you are going to delete a node, and if that is the last node, then what should be the case?
We have to check the previous one, sir, and the next one. If next one is not there, just we
We
need to.
consider you are going to delete 9. We will check whether it is having previous node. Yes. 9. Whether it is having next node.
No.
No. Previous node means just break this link. Then what should come here? You
Null.
can.
Null.
Sorry?
We will write there null, sir.
Sorry, I didn't get you.
In
If you break this
2006.
link,
Blank null, sir.
exactly. If you break this link, the 4 will be the last node, right?
Yes,
If
sir.
you break that one, the link list will look like this: 2004, and this will become 4 and 2003, 2006. If you break this one, this node will go completely. Then this is the last node, and last node next address should not be any address because there is no next node, right? So this will be NULL.
Null.
Null will come here. So what you need to write, break the link and make the address of the last node as null. That's it. Got it?
Yes, sir.
Yeah.
Yes, sir.
And what happens? The element, if you are going to delete, will be the first node. మీరు ఏం డిలీట్ చేయబోతున్నారో అది ఫస్ట్ నోడ్ లో ఉంటే పరిస్థితి.
And the
Can you tell?
Yes, sir. 5 అన్నది అది పోతుంది. 4 ఫస్ట్ సెకండ్ వన్ థర్డ్ వన్ 2 ఉంటుంది.
If you want to delete this node, just change this head to here. Why should we change? This indicates that this is the first node. See, if you delete 5, this look like this. 4, 2006. This is 2003. 9, null, 2006. Blank will be there here, and we will move this head to here because this is the first node. Every first node will have the head. Got it or not?
Yes, sir.
Yeah, this is insertion, deletion, we have done, and remaining we will discuss tomorrow. We will discuss these more operations, double linked list and circular linked list. Is it okay?
Alright.
Yes, sir.
Any doubts in the today's class? What is the list? What is ADT? What is how this list can be implemented? What are the types of linked lists?
How to insert at the beginning, at the end, and at the middle, sir.
Okay, friends. If it is okay, then if you have any doubt, and let me know, and feel free to ask and prepare well for the exam. Can I close?
No doubt. Clear.
Yeah,
Yes,
fine.
sir. Yes, sir.